We have our Unit 7 test this Friday. So today we are doing the odd questions of the review, and then you can work on the evens on your own after the video, or you can pause the video and try the evens as you go. So let's start with number 1. So in this unit, we are talking all about exponents and polynomials and what to do when we add, subtract, multiply, and divide. So what we have in the very first one is a plus sign between your two sets of parentheses. So that means that we need to add. So the rules for adding say that we need to drop parentheses because we are adding. So we drop parentheses first, and then we combine like terms. So we need to make sure that when we are combining like terms, we are combining terms that have the same letter. So the letter with its exponent has to be the same. So in this one, it's in kind of a weird order, but that's what they like to do on stars. That's what we're practicing for. So I'm going to start with a term that has the biggest exponent. It's right here. S to the second power is called the leading term that we have here because it has the biggest exponent. So notice when I circled it, I circled the number and I circled the sign so I know what type of 6 it is. So its like term, its friend, is the other s squared term. So in your calculator or in your brain, what this is saying is -6 minus 3. -6s squareds minus 3s squareds is -9s squareds. So now I'm going to cross out that term because I have combined those letters. So the next one here is an S. So the next term is going to be the term that has an S in it. Again, I'm going to circle it with the symbol that was in front of its number. Its like term is the other one that has an S with it. So this says positive 8s plus 7s. 8 plus 7 is the number 15, positive 15 with an S. Notice I don't touch any exponents. I'm just adding the number in front. So it's called combining like terms. So our S term is now combined. So last but not least, we have a constant. Its number is 5. And we have another constant right here, which is the number -12. So you can do it in your brain or your calculator, I don't care. So you have 5 minus 12. 5 minus 12. That's going to give you the number -7. So in this first one, that was called adding polynomials. There was a plus sign between. So what we did is we dropped parentheses and then we combined like terms. So you can try number 2 if you'd like to do another one of those. Go ahead and drop parentheses and then combine like terms. Okay, let's take a look at number 3. So in number 3, notice there's no plus or minus sign between any of these parentheses. So what that means is that this is multiplying. So these are called monomials because that's one term, it's one chunk of math. That's a monomial, and that's also a monomial. So the rule for monomials is number 1, we need to multiply those big numbers. It's called the coefficients. We multiply the coefficients. Step 2, it's a little ugly. We're going to count the letters. So that's the rule for multiplying monomials. We multiply the big numbers, those coefficients get multiplied, and we count our letters. But before we do that, we have this weird term right here called x to the 0. What x to the 0 means is that there's no x's right here. So before we even start, I'm just going to cross out the base, which is x, and that exponent of 0. X to the 0 means there are 0 x's there, so we're not going to include that base. So now we're ready to go. So we multiply the big numbers. Those are called coefficients. So 4 times 5 is 20, times negative 3 is negative 60. Okay, so we multiplied our big numbers, our coefficients. Now we count our x's. There are 2 x's here, and there are 2 x's here. So that gives me a total of x to the 4th. X's are done. Then we have a y. So this here is y, which is the same as y to the 1. So there's one little y, no other y's, just that one. So we just have one y in this question. Notice I didn't count this x because it was x to the 0. You can just cross it right out. Keep the coefficient, keep the big number, but you can cross out that x. So this is our final answer for number 3. We multiplied those coefficients, those big numbers, and we counted how many of each letter we had. So you go ahead and you can try number 4, and we can keep going through the odds. Let's look at number 5. So in number 5, this looks difficult, but it's not that bad. It's really important, but it's not that bad. So in number 5, the only thing that's different here is there's a little 2 on the outside of the first parentheses. What you learned that last week is that's called a power raised to a power. So that's an exponent raised to another exponent. When we have a power raised to a power, we draw blanks. It was a 2, so I draw 2 blanks, and then on those blanks, I write what was inside the parentheses. That's a little ugly. X to the 4th. Okay, so what was on the blanks, 2 little blanks, done. What was inside parentheses goes on the blanks. There's also a 2x to the 3rd in this question. So we multiply, go back to these rules from number 3. We multiply all of our big numbers. 8 times 8 is 64. 64 times 2 is 128. Okay, so I multiplied all those big numbers. 8 times 8 is 64, times 2 is 128. Now we count our letters. There are 4 x's here, 4 x's here, and 3 x's here. 4 plus 4 is 8, plus 3 more gives me x to the 11th. Okay, so we had to take care of the power first. That means I needed 2 of that first piece. And then I dropped down the next one so that I can use the rules for number 3. Multiply those big numbers and count your exponents. You can try number 6, same idea. Okay, let's take a look at number 7. 7 is even easier than 5 and 6 was. So what we said is when we have a power raised to another power, that means there's an exponent on the outside of those parentheses. When this is a whole number, we draw that number of blanks. It's a 3. So I drew 3 blanks, and now I don't need that number anymore. On those blanks, I'm going to write down what I had. I had x squared, y negative 4. X squared, y negative 4, x squared, y negative 4. There are no coefficients, there are no big numbers in this question, so I can just go straight in and count my letters, starting with the letter x. 2 x's, 2 x's, 2 x's. That's a total of 6 x's. Then I have some y's. Negative 4, minus 4, minus 4. Negative 4 minus 4 is negative 8. Minus 4 more is negative 12. We could move that negative exponent below, But for this test, that's all you have to do. Expand it and then count your x's. You can try the same thing with number 8. On number 8, this a is a to the 1. Squeeze a little 1 in there. So this is like saying a to the 1, b to the negative 4, and then 2 blanks. So you can try number 8. Okay, number 9 is very, very important. It's not difficult, it's just a little bit different. So hopefully you remember when we did this in class. In this one here, for years, I always said, a power on the outside, draw blanks, and then just do your regular multiply rules. It was always easy. Everyone always got it right. But then the STAR test came around and they were like, oh, no, that's too easy. So they gave us a fraction out here. I can't draw a fraction of a blank. It's not going to work. I can't do that. So what we have to use is a different rule. So this rule is called distributing. So if it's a fraction, I want you to give it to each term. What that means is we had the number 49. We're raising it to the 1/2. Then we have the phrase x to the 8th. We're giving that a 1/2. Finally, we have y to the 12th, and we're giving that a 1/2. So this is very important. The big number has to go in the calculator. 49, so you'll type in 49, and then you'll raise it. There's a little, we call it a caret. There's a little button there that looks like, I don't know, the top of a house. So find that button, and then press Control Divide 1/2. The calculator will tell you that 49 raised to the 1/2 is the number 7. So now, when we have these, 1/2 times 8 is just the number 4. Then this one here, 1/2 times 12 is just the number 6. Okay, so we distribute it to each term. We give the 1/2 to each of these terms. Use your calculator for the coefficient. For the big number, plug it in, 49 raised to the 1/2. Then the exponents, you just multiply, you just distribute. 1/2 of 8 is 4. 1/2 of 12 is 6. Go ahead and try the same thing for number 10. Not too difficult at all. Okay, next. Let's take a look at number 11. So in number 11, this was an old STAR test question as well. We will never teach something to you if it's not something that we are required to teach. And so in this one here, number 11, the thing that gets people is the wording. So the wording of this looks really difficult. You see all these big words. You're like, oh, too hard, can't do it. But you can do it. It's not that hard. So let's do number 11. So number 11 is similar to one that we had done earlier. So what this is saying is we have x to the 30, okay? X to the 30. Then we have a power on the outside. You have two options. You can distribute it or you can draw blanks. I'm going to draw blanks here. Okay, so 4 is on the outside, so I drew 4 blanks. X to the 8th is on the inside, so I put x to the 8th on each of those 4 blanks. Okay, so now my multiplication rules. What we do here is we just count our x's. How many total x's do we have? We have 30 plus 8 is 38. 38 plus 8 is 46. Plus 8 plus 8. That's the number 62. So we just counted our x's. We always count our x's. So we had x to the 30, then I had to write x to the 8th 4 times, and then I counted all of my x's, the green ones and the blue ones. So now the question is, if this thing is equivalent to x to the p, what is the value of p? Well, p is just the exponent. What is the exponent? It's right here. So the answer is just 62. So this is often a bubble question where you have to bubble in the number It's not going to be multiple choice. So I had to solve it first. And then it says, what is the value of p? Well, p was the number in the exponent. So the number in the exponent was a 62. Easy. So try the same thing with number 12. Same idea. Okay, so with number 13, you guys did this for several days. This is one of the most important things that we do in Algebra 1. So multiplying binomials will happen for the rest of your mathematical career. It is a very, very important skill to know from Algebra 1. So in number 13, it says, find the product. Don't let the words confuse you. This just means multiply. There's no plus sign there. I'm not adding. Between those parentheses, there's nothing there. So that means we multiply them together. So when we multiply, we just distribute. So for the sake of understanding why, let's put ones in the front. And then I'm going to put a little 1 on each of my x's because there's one little x there. So what we do is we take this first term and we distribute it to both of my terms. So what this says is 1 times 1 is the number 1. X with another x makes x squared. 1 times negative 7 is here. Be careful. That's a negative 7. So 1 times negative 7 is a negative 7. There's an x there, so I keep the x there. So I have now distributed this first piece to both terms. Okay, first one is done. So now I'm going to take my second piece and I'm going to distribute that to both terms. Negative 3 times 1 is negative 3, and there's an x there. Negative 3 times, be careful, this is a negative 7. Negative 3 times negative 7 is a positive 21. So this is called double distributing. I distributed the first term, and then I distributed the second term. So when you do this, the middle will always be a like term when we have a binomial times a binomial. So my final answer, 1x squared, gets to stay. But these can be combined. Negative 7 minus 3 is the number negative 11x. That's wrong. It's 10. I can count. 3. Negative 10. There we go. X. Notice it's not x squared. It's just negative 10x. And then the back number gets to come down. If you did not put this 1 in front, it's the same. You can do it with the 1 or without the 1. Either is correct. Okay? Double distribute. Combine like terms. Very easy. Try number 14. We're going to do the same thing a couple more times. Number 15, I'm going to take my first term. I like to circle it so you have a visual. And I send it. Make sure you're drawing arrows. When you don't draw arrows, that's when people start to mess up. I know some of you guys do something called the box method, which means you put it around a 2x2 box. I taught it like that for years. That way is perfectly fine. If you'd rather do box method, go right ahead, but make sure you're getting the right answer. Your answer should match my answer. Okay, number 15, double distribute. Here we go. Whole number, coefficient, big number, 3 times 2 is the number 6. This has an x, this has an x, so together they have 2 x's. Next, 3 times, be careful, that's a negative 4. 3 times negative 4 is negative 12. There's an x in that one, so it gets the x. First term is done. Now I move on. Here's my next term. I send it to both of those. 2 times 2 is a positive 4 with an x. 2 times negative 4 is a minus 8. You'll see a pattern. We have an x squared in the front, we have x's in the middle, and we have a constant in the back. So my final answer is 6x squared, that just gets to come down, negative 12x's plus 4x's is negative 8x's. You can use your calculator if you need to. Negative 12 plus 4 is a negative 8. And there was an x with them, so we keep an x. The number in the back is just a minus 8, so it gets to come down. Okay, we keep the front and back, combine like terms in the middle. Try the same thing with number 16. Number 17, do not try to do a shortcut with this one here. You will, they'll trick you, you'll get it wrong, you don't want to do that. So in number 17, what this square means, like we did earlier in this review, the square means you have to write it twice. I need to write this thing 2 times, 3x plus 4 times 3x plus 4. The answer is not 9x squared plus 16. That is not the answer because there's going to be a middle term. Ignore the 4th dog that I just brought home. He might be snoring and scratching me. All right, 17, moving back in. Okay, so 17, I needed 2 of those things, so I wrote them twice. Now I just double distribute. Take your first term, distribute to both of those terms. 3 times 3 is 9. Let me make that a little bit smaller. This is kind of gigantic. X with another x is an x squared. 3 times 4 is the number 12. There's an x here, so it gets an x. First term is done. Next, 4 is my next term, so I distribute it to both terms. 4 times 3 is a 12 with an x. 4 times 4 is positive 16. Distributed the first term, distributed the second term. Like terms are in the middle. Final answer, 9x squared gets to come down. You had no like terms. 12 x's and 12 more x's is 24 x's. 16 was in the back, so 16 gets to come down. Easy. Go ahead, try number 18. Do not try to just square the numbers. It won't work for you. You have to write it twice. And then distribute both terms. Very easy. All right, let's look at number 19. So on number 19, this is how they put it on star a couple years ago, so they might do it very similar again. So what we notice here, there's 2 ways you can do this. We have a trinomial, times a 2, which is called a binomial. I much prefer to put the smaller one first, the one with less terms. So let's rewrite this as negative 5b plus 6 times b squared plus 8b minus 2. It just makes it a little bit more consistent with what we did before. It's the same thing. I just put the binomial in the front. So I just rewrote this, the binomial's in the front. I'm going to drop a 1 in front of this b squared so it doesn't confuse you. Okay, so again, we circle our first term. We distribute it to each of our terms. Okay, negative 5 times 1 is the number negative 5. Be careful. B to the 1 and B to the 2 make B to the 3. Negative 5 times 8 is negative 40. A B here and a B here makes B2. Negative 5 times negative 2 is positive 10 with a B. I know that some of you guys have your teachers tell you to stack it underneath so it's easier to combine like terms. That's fine too. We'll do that in this one. So the first one's done. It got distributed to all of its terms. That one is done. So now I take the next one and I distribute. 6 times 1 is 6 That's b squared, so it's 6b squared. 6 times 8 is the number 48. I'm running out of colors. So 6 times 8 is 48. And there's a b there. Last but not least, 6 times negative 2 is negative 12. So now we just combine like terms. Negative 5b cubed had no friends, so that just gets to come down. Negative 40b squareds and a positive 6b squareds gives me a negative 34b squared. You can use a calculator if you need to. We had 10 b's plus 48 b's. It's 58 b's. Then we had negative 12 hanging out in the back. So negative 12 comes down. Okay, it's big. It seems difficult, but it's not that bad at all. So in this one here, we had to distribute. I rewrote it first. Same with number 20. Go ahead and rewrite it so that binomial goes first. You could keep it like this, but the annoying part is that you'd have to send each of these pieces to those things, and it just gets too ugly. There's just a lot of arrows there. Not that this is much prettier, but I would suggest, highly suggest, rewrite it negative 2x plus 10 times x squared plus 3x minus 4. It's very useful. Put that 1 there, put 1 here, put 1 here. X is without an exponent is just an invisible 1, so just put a 1 there. Okay, so go ahead and try number 20. Same idea, not too difficult. We're going to switch over for a second video for the last couple of questions here. So this got us through multiplication, and then we'll use the second video for all things division.